welcome to the Kong Builders live stream. My name is Kat Morgan and I will be your host today. So if you've ever attended a Kong Builders before, you know that this is a fairly informal event. We are going to be diving into some Kuma mesh topics today, specifically focusing on ARM devices and all kinds of fun things like that. If you're new to Kong Builders, though, I look forward to introducing you to all things Kong. Here at Kong, we do create an API gateway, a Kuma and Kong mesh. That's the open source and enterprise versions of Kong mesh. And then we also have, you might have seen Insomnia around, which is kind of analogous to Postman if you haven't heard of it. So, kicking things off, we will go ahead and encourage you to speak up in the chat, say hello from wherever you are. Let us know where you're tuning in from. If you have questions throughout, feel free to drop them in chat and I will take them one at a time as they fit into in between what we are working on. And as far as the specifics of today's agenda go, we are going to be taking a look at a new feature in the Kuma mesh for that ARM support that I mentioned and taking it for a spin just to see how far we can go with it. Specifically, we're going to be using it on a Raspberry Pi cluster that I built yesterday. It's going to be running Talos Linux and clustered Kubernetes on top of Talos. If you haven't heard of it, go check it out. Quick Google should take you right to all of the helpful documentation and Slack for that really neat Kubernetes specific OS. Catch me on Kubernetes Slack or Talos Slack at any time if you want to ask me questions about it. And with that, let me go ahead and jump to the Kuma docs. All right, so first off, taking a look at the release announcement, we just released Kuma 170. Of course, that's Kuma, the open source version of the mesh. And we are specifically going to go ahead and try out our ARM support. I'm going to be running most of the commands today from my local system. So let's make sure that we have that environment set up. All right, we have my Talos Pi cluster. And it looks like all pods are good. So let's go ahead and actually take a look just real quick at what our baseline is for this cluster. We have 17 pods, everything's running well. We'll kind of keep an eye on how that changes over time while we're working on our deployment today. And jumping back to our Kuma website, let's jump into install docs. So we're going to be going with the Kubernetes install. Kubernetes installs include a few different routes to getting Kuma installed in your cluster. You can use Kuma-Cuddle. We're going to be taking that path ourselves. We are going to try copy pasting the directions as much as possible and deviate only as necessary. And then there are also options for Helm install, which is completely valid pattern. I'm going to try and minimize the amount of values files and YAML editing that we have to do here. So without further ado, let's see. I believe I got rid of my Kuma-Cuddle. Good. All right, so we are starting literally from scratch. So we're aiming for the 170 version, which is what includes the new ARM support. And I think this is actually going to fail. So we're just going to be kind of uncovering the experiences here today. So of course I'm on Fedora. This curl install script does not work for Fedora, so we're going to hack at that just a little bit. And that is what, there it is. So this is the Linux AMD 64 download. So we're going to unpack this. All right, and of course that is the 170. All right, so as you can see, there are several different things involved in, or included in this. I'm going to add that to my path, and now we should be able to see we have Kuma installed. So before today, I did actually double check this on my Mac M1. Of course, that is ARM based, and Kuma works just fine in my experience on the M1. Does Kuma work? All right, yeah, does Kuma work with Kong Community? So Kong Community Edition, I'm guessing you mean the Kong API Gateway, that Community Edition. In that context, yes, the gateway can be used, the open source version, for that ingress, the north-south traffic into the mesh. Of course, the mesh itself is most commonly seen as valid for that east-west traffic control, so service to service within one or many clusters. And then the Kong gateway, the API gateway itself, can be used as an ingress controller and a general API gateway with plugin expansion options and things like that. The open source version will work as the entry point to your mesh. If you're curious about the differences between the open source version of Kong Gateway or the open source version, enterprise version, things like that, I think last week we did a Kong Builder session specifically on that, so feel free to go look for that and drop any comments on that video if you'd like to learn more about that in the future. All right, so we have Kuma. We are going to go ahead and run. So in this case, we are not doing x86. We're deploying to an ARM cluster. We're going to notice that, let's spread this out a little bit. I hope you all can see okay. We're going to be specifically selecting the ARM64 nodes. So let's actually all right, so we have our nodes here. And sure enough, we have our ARM64 label on those. So we're going to go ahead and copy paste this and see what we get. Let me see. Hopefully that helps a bit there. Okay, so just so you can see that command that we ran, we are using the Kuma install method. We're installing the control plane right now. So the Kuma mesh, there is the data plane, which is each individual proxy that you'll see alongside the services where you schedule the mesh, and then the control plane, which orchestrates all of the data plane proxies. One thing to keep in mind when you're talking about Kuma mesh, there can be as many as 2 different control planes that you would want to talk about in a given deployment. You're going to have your cluster control plane, which would exist in each given cluster that might be part of a larger mesh. And then you could have your global control plane, which is optional. And if you're interested in that, drop a note in comments. We'll get into that in the future. Today, we're going to do predominantly a quick start style install and not get really aggressive with the types of features. We're just looking to see if we really have that ARM support that we're looking for. So in light of that, let's go ahead and check out our cluster and see how it's doing. We have some pending pods. Let's see if those are going to play nice. All right, so jumping back to my terminal, we have some pending here. I wonder, this is a 3-node cluster, so it's all control planes. You know what? Apologies, I need to remember how to remove. There we go. All right, so yeah, that's a good question. It looks like we just got the question, what is the specialty of Kuma over other service mesh, and is there any performance impact? It's a really good question, and part of designing a good mesh, part of designing a good mesh deployment is identifying what the overhead is going to be for each of your data plane, where you're going to schedule your control plane or control planes, and how much overhead you're going to be allocating for that. Control planes are generally going to be fairly negligible in your overall overhead. It's the data plane where you're going to be implementing a proxy per service that you have scheduled in your service mesh. That's where you're going to start really adding up the cost, the hardware cost, the compute cost of your mesh, and the network traffic overhead. So generally speaking, we are seeing the typical well-optimized Envoy overhead for the network traffic itself. The compute overhead just really depends on how many services you're scheduling your data plane proxies on. If you have a very specific app built cluster and you're just running that one or small set of apps on your cluster, you're not going to be running that many proxy data planes. If you're looking at a large multi-tenant cluster, it's a really good time to go ahead and plan what makes sense to be part of your mesh at that point, and whether it should be part of a monolith cluster or part of future designs for other multi-cluster setups. One of the fun, unique things that I want to show off about Kuma Mesh in the future is actually we are the only mesh that I know of that supports adding non-Kubernetes nodes to your service mesh in a hybrid fashion. So you can have Kubernetes mesh and you can have non-Kubernetes nodes as part of your Kubernetes service mesh. Or in really crazy scenarios, you could actually implement an entire service mesh without any Kubernetes whatsoever. So there's really a lot of opportunity, especially if you're looking at possibly integrating DevOps in a containerized or container native journey to an organization that already has extensive infrastructure. And there's going to be a path to include your existing services as part of your mesh while you onboard them a little at a time onto your Kubernetes clusters. That's actually a talk that I'm going to be presenting more on at Kong Summit. So if you get a chance to attend in San Francisco or catch some of those talks later, definitely make a point to check it out. All right, so getting back to my cluster, we need to there we go. All right, let's see if, all right, so sure enough, I have that taint on my master nodes. That's going to be scheduling. And we've got an error. So we have, that's interesting. I hope you can see this well. It looks like we have an AMD 64 image scheduling to our ARM nodes. So let's get into that. I wonder why it's specifically tagged AMD 64. Okay, well that's fun. Let's do this actually. We have, let's filter. Apologies for the train noises. Live in a West Coast port town. That train is running all the time. Okay, it looks like we have an ARM 64 image, and it is multi-arch though, so I should be able to, I suppose I can specify ARM 64. I'm gonna try and just rip off okay, let's see if that helps. All right, we have a new container creating. We'll see if it pulls. If I jump over to all right, if I jump over here to Lens, I use Lens a lot. I haven't sat down to learn K9s yet. I definitely want to. I know a lot of people really like that one. All right, so we have a running control plane. It looks like we get to file a bug. All right, so with the control plane running, let's see what our docs recommend doing next. Actually, I'm gonna make sure the logs are nominal. Sorry, I've been watching too much space race news. Christian, if you were on the live stream right now, I'd be like pulling for you to make choo-choo noises. I'm sorry, I can't help it. I guess there's always an opportunity in the future. Okay, so it looks like our logs are good here. Let's jump over to docs and see what we're doing next. So of course, we're going to see everything coming up correctly there. So, all right, so mesh, control plane, configuration, and management. What are different options that we have there, right? The part of the docs that we're looking at right now, that aptly implies that we have a few different routes of management. We do have a GUI. That web UI is going to be read-only, I believe, in the case of Kuma. And we will see if we get far enough to go all the way to Kong Mesh today, that an enterprise licensed version of Kuma with some of the additional bells and whistles as part of that enterprise feature set. If not, we'll pick another day and dive into that, kind of like we did a comparison of open source and enterprise features in last week's in the last Kong Builders episode. Let's go ahead and see if we can pull up the GUI and just take a look at what we get there. Cool. We have a GUI path endpoint. Ooh, yes, sweet. Okay, so we're going to be running the control plane. Let me zoom in on that just a little bit. And assuming that comes through clearly. So there's some quick start options here. Again, this is a read only, so I haven't played with the welcoming onboarding kind of click through menu a whole lot yet on the Kuma Mesh. You guys are along for the ride with my personal mesh learning journey. So if we mess things up, it'll be exciting to see how we recover. And that's all I'm going to say. We're doing standalone deployment today. Of course, this is going to be where we're only thinking about Kong Mesh in terms of a single cluster. And then multi-zone deployment is where we actually get to carve up a cluster or carve up a mesh that might be multi-cluster into different zones. They can be different global regions or different availability zones or all kinds of different ways of carving that up. And let's see, so how are we configuring our storage? So this comes down to our configuration options for the mesh itself. Are we using the API, or are we using Kubernetes API and custom resources? You may have noticed when we did our Kuma cuddle install command, there were a lot of different CRDs being installed at that time. Today we're going to stick with the Kubernetes backend. So we're just going to continue with default here. Postgres is another thing that we'll talk about use case for, where we're talking about more global control plane stuff in the future. And we have a default mesh. So let's see, I wonder if we should try a demo app on ARM. The mesh supports it, but does the demo app? I have honestly no clue. There's only one way to find out. All right, so Kuma cuddle apply. Actually, let's do this. See, it looks like Kuma system. Okay, we don't have anything new yet. That's because pod would need an annotation for data planes to be scheduled. I wonder if the image is going to be scheduled multi-arch correctly. We shall see. All right, so let's jump over to Lens real quick and take a look at what is deploying now. So our namespaces, we now have Kuma system and Kuma demo. And we have some pending pods. Let's jump to terminal here. We have an init error. Let's see if it's the demo app itself. It might just be that the demo app is not multi-arch. All right, let's go check that image out in Docker. And we do have multi-arch. Okay, so I would suspect is there any other image? Let's check Redis. All right, Redis should be multi-arch just fine. Okay, so let's check out this error specifically. Pod initializing. All right, let's jump into Lens and poke around a little bit. And we have waiting to start, Kuma init. Ooh, failed. Okay, so this is going to be the Kuma init, which loads before the sidecar to set all the traffic rules, and that's fun. Okay, so let's actually grab that log in terminal. -C is going to give me container option. We're going to do init. Yes. Okay. let's go ahead and click through and see if we get any details in the console or what kind of things we get in the console. I have not explored the console enough. Let's see, no traffic logs, of course, because we have no data planes running. This is our overview of the mesh. Of course, we haven't configured anything, so we only have the default zone. We should have 2 data plane proxies because we are deploying 2 services in our sample app. And all right, let's see if we can find anything useful in here. It is showing, of course, that it's offline. Okay, so we're not going to get anything that I can see useful out of the console. So let's jump back to all right, so here in Lens, I hope I'm zoomed in far enough that you can see kind of where I'm heading around. This is going to be IP tables rules going to temp directory. I honestly wonder if this could end up being caused by the Kubernetes version that I'm running. And know that there are some more frequent read-only file systems in Talos, for example. So in today's episode, we are taking a new feature of a just released version of Kuma Mesh and testing it on Talos Kubernetes, which is actually I'm running a 1.1 beta 2 of that Kubernetes distribution. It's been rock solid for me, so I was pretty confident on that. One unique thing about Talos is there is no shell on the nodes itself. It's all API driven. Apologies. Oh, yeah, I should speak up more. Thank you for the reminder. I hope you can hear me when I do speak up. So we're working on nodes that have no shell, and they're all API driven. Another really interesting part of the Talos Kubernetes deployment is it is predominantly a read-only file system. So I'm honestly wondering if that might be something we're running into here. I have an EC2 instance set up, which is a Graviton-based instance, and we can jump to that and retry this stuff, I think, pretty quickly if I need to switch over there. And that would be more traditional Kubernetes. I'm honestly inclined to guess that that is what's happening here. Actually, let me see if that's okay. That's all I'm getting there. All right, so reading what I have here, I really do think that it's probably, I don't know, temp directory should not be read only though, not even in Talos. So let's go ahead and alter course. I'm going to set this stuff up really quickly in the Graviton instance. So I have that here. And I was hoping not to run into a hiccup at this stage. Well, I honestly am... Okay, so question, are you saying at the mesh level that running on Talos's read-only file system is not practical? I am not a Talos expert yet. I might have been going a little bit out on a limb to run Talos with other new stuff that I haven't practiced yet. I was definitely interested to see how it all fits together. And that's kind of why I have a Graviton instance here that I'm using as a control. And I probably should have set microcates up for starters in the Graviton instance before the episode, but I was working on a couple other technical difficulties instead, so I didn't get this going yet. Shouldn't take too long to get this set up though. And as far as the read-only file system goes, so there are a couple of things that I have seen on Kubernetes in general with that, like heightened security, and whether it's read-only file systems or other container optimized OSs like CoreOS or what have you, there's always going to be learning curves to adopting something that does deviate from just a typical Linux host. The same can be said for, actually I have a terminal over here that I wasn't showing, was I? The same can be said for Windows worker nodes or all kinds of other things. So it makes sense that we would be running into learning curves. Kong Builders is part of that, just seeing what it's like to work with Kong products in a daily practice scenario and troubleshooting things as we go. All right, so I'm also going to do grab kubectl here real quick. Sorry to put you through waiting on me for this part. All right, so we just posted our kube config, and let's see. All right, we do have a running microcates cluster. So let's go ahead and jump back to grabbing our Kuma cuddle. And we're going to go to the Ubuntu ARM64 because we're going to be running this on the Graviton instance, which is ARM. And here we're going to go ahead and extract this out again. All right, let's go ahead and copy kubectl. And there we go. Okay, so you'll notice now we are running the ARM64 version. Now, one thing that's really interesting to talk about is what else is in this larger tar file. Basically, this tarball includes everything that you need to run a Kuma mesh from scratch. So if you are not using Kubernetes, or if you are taking a standalone non-Kubernetes node and attaching that to a mesh, there are binaries in here, like the Kuma data plane binary, which help you set up a node attached to a larger mesh. And we will pick another Kong builders to actually practice that in real life and see what we get. Okay, so we now have our Kuma cuddle, and we are going to install. So let's jump back to, if I remember right, the single node micro-K8s cluster is not going to need us to remove the taint. Yeah, so Brad Connor spoke a little bit about the fact that they are deploying on Talos. I am very interested in that, and I try to be active in the Talos Slack when I can be. So if you want to collaborate on those things, if you find yourself at an intersection of looking for a mesh and wanting to run it on Talos, I am 100% on board with hacking away at that with you as well. So I'm glad you joined us and are exploring the possibility of that with me today. All right, I don't have my K alias. What am I going to do? All right, so we have our control plane. Interestingly, we did not need to edit the deployment in this case. It just naturally picked up the ARM image, apparently. So that seems like an interesting edge case. That will be fun to explore. Let's go ahead and take a look and see. Okay, so in this case, it is hard coding. I wonder actually if that hard-coded tag comes down to the specific Kuma cuddle binary that I'm using. I'll explore that more, and when I file the issue on the Kuma repo, we'll have that solved before I file the issue. I'll be able to speak to that. Since, okay, so part of a I don't know how many of you are familiar with platform images, but one of the neat things about container registries, the container manifest that is published with when you do a Docker push to a registry, is you can actually get an annotation in the OCI manifest, which identifies what layers are for what platform. If you've only built an image for x86, AMD 64, then you're going to have an annotation in that manifest declaring that it is only for that platform. And that's how you can go to Docker Hub, as we did, and see what architectures the images are for. Now, if it lists two architectures, like this one does, the Linux AMD 64 and the Linux ARM 64 V8, then what you get is what's called a multi-arch image. And each individual node that's running containerd or cryo, that's your runseek or your CRI interface, it will identify what platform the CRI interface is running on, and it will pull the correct image by default unless otherwise specified in the deployment manifest, which we saw hard-coded to that additional AMD or ARM64 tag, right? So we generally want that to default to not explicit in the tag format so that we can instead let the nodes pull the right image for the platform. And that's what we will file a bug to help get resolved. So with that, let's see if we can deploy our sample application. Okay, so it looks like it created our namespace, Kuma demo. We got our deployment for Redis, which is going to be the back end of this application. And we have our service for definition for that Redis service. We also have the deployment for the demo app and the service for the demo app. So let's take a look. Hey, and in this case, we are running. So it looks like there's going to be some interesting edge case to solve for a unique cluster type like Talos. Cool. All right, so with that, we have a sample app. We've taken a look at the control plane a bit. I wonder if anyone has any other questions that we can explore for the next 10 minutes or so. Otherwise, I was going to continue with the documentation as is and see what kind of other quick start stuff we have that we can just kind of dig through. If you have any other questions or interests on this general subject, drop it in chat and I'd love to talk about each of those. Let's see. So the different ways to use Kuma. We have our GUI, and that was that web UI that we just looked at a bit. We can also use kubectl to create resources. There are several different CRDs specific to Kuma. We can actually jump into Lens, for example, and take a look at what kinds of CRDs we have here. I really like this for exploring some of the CRDs when I'm not familiar with exactly what I'm looking for. So let's close this out, and we can see there are a lot of CRDs in the Kuma CRD group. So a lot of these are worthy of their own Kong Builders episode, just playing with the different CRDs, experimenting with them in a deployment scenario. There is going to be OPA integration if you're familiar with Open Policy Agent and expressing packet handling policies that way. Again, OPA usually returns just a true or false. So you can create rules to explicitly reject or explicitly allow packets with that integration. Of course, we do have Mesh Gateway, which is how we actually implement multi-zone. So if you have two different zones and they need to talk to each other, that's going to be basically two logical groups of your mesh services that are isolated from each other at the mesh layer. And you're going to be able to create paths for those services to talk to each other through a mesh gateway. Basically, if you think about each logical zone as separate east-west data planes, then when those zones communicate with each other, we go back into that north-south mode of thinking, and the gateways on each zone are how you would implement that north-south traffic handling, which is fairly unique to Kuma, if I recall correctly. Of course, rate limit is its own resource that we can set, retry counts, all kinds of different CRDs which represent each functional capability of the mesh itself. So jumping back to the docs, that is basically what this section, the kubectl, CRs are talking about, where we create those, in this case, an MTLS. And then, let's see. So there is an API for the control plane, which you can call directly. If you're familiar with Kong Gateway, you'll know that the Gateway API has, or the Gateway itself has its own admin API, and you can configure all aspects of the Gateway through that admin API. It's kind of that source of truth. The mesh being originally written for and designed for Kubernetes, it is natural to use kubectl resources to configure it. However, when you remember that the Kuma mesh can exist completely independent and outside of Kubernetes, you have to make sure and implement a method of controlling the mesh. And that is where this API comes in handy. And in the enterprise version of the mesh, you're going to see that be read and write. And then kubectl is a read CLI interface for the mesh itself as well. I haven't seen any other questions coming up yet, but I think that should pretty well show that it was interesting to see some differences between running on two different versions of Kubernetes. Talos and MicroK8s are both Kubernetes, of course. Under the hood, they have their various differences. MicroK8s is one of my go-to options for testing and development. And Talos is one of my favorites on the Raspberry Pis for lots of reasons. Catch me on that Slack to find out more why. And then I think with the CRDs that we took a look at and skimmed over, there's a lot of opportunities to do a Kong builder in the future, exploring those. Let me know if you have favorites or any that specifically stand out to you for prioritizing in future episodes. And with that, I think we've covered everything that I intended to today. Let us know in comments when the videos post. If you try this on your own, what kinds of results you get. Find us in the Kuma Slack. There is a public Kuma Slack you can join. And I will be in there looking forward to hearing about all of your experiences with the mesh. And until next time, peace and have a great rest of your day.